Yeah, good evening, dear students. Just I will revise what I discussed in the previous class, then I will continue. Today, almost I am going to discuss these questions. I can write this one. Just I will revise that integration only. I am discussing today integration 3 or 4 marks questions. I am discussing 3 or 4 marks questions. Yes. See, in the previous class, I have discussed about, integral minus 1 to 2, x cube minus x dx. This is the previous problem I have discussed about this. Minus 1 to 2 mod x cube minus x dx. So, if you find the factors of x cube minus x, I can write x into x square minus 1, x into x minus 1, x plus 1. So, here, this is modulus function. So, this will be 0 at minus 1, at 0 at 1. But they are given limitation up to 2. Then I would split the function minus 1 to 0, 0 to 1, 1 to 2. Between minus 1 and 0 it gives positive, 0 and 1 it gives negative, between 1 and it gives positive. Since mod x equal to x when x is positive, mod x equal to minus x when x is negative. Using that concept, I have simplified this one. So then I have written this one. Since positive, between minus 1 to 0, write positive x cube minus x. Between 0 to 1 negative, take minus of x cube minus x. Between 1 to 2 positive, x cube minus x. Then you do the simple thing, simple calculation, x cube is x4 4 by 4 minus x square, would apply the limits. Here also the same thing, apply the limits, you simplify. But many people, they made a mistake in the simplification. You should be careful when you are doing simplification with the signs and small numbers. With overconfidence, they may do mistake. Be careful. The final answer will be 11 by 4. That one we got it. Now I will continue. So today the questions what I am going to discuss, they may ask 3 or 4 marks questions they may discuss. The questions may be 3 or 4 marks. They will ask for 3 or 4 marks. Now we will follow that. 3 or 4 marks they may ask these questions. Now I will continue now. See the next question what I am going to do now. So all important models I am going to discuss. Don't miss this. Integral 1 to 4. See the next problem. Integral 1 to 4. Integral 1 to 4. Mod x minus 1. I can write. This is a mod x minus 1 plus mod x minus 2 plus mod x minus 4. Mod x. This is mod x minus 2 plus mod x minus 4. Like this I given dx. This model is important. Like this I given this one. Here also you can check that 1 to 4 and mod x minus 2. So our convenient I can split this integral 1 to 4 mod x minus 1 dx. Integral 1 to 4 mod x minus 2 dx. Integral 1 to 4 mod x minus 4 dx. Again remember the definition of mod x. But the definition of mod x is equal to x when x is positive and equal to minus x when x is negative, equal to 0 when x equal to 0. Remember the definition of mod x. If you take between 1 to 4, always this value can think. Between 1 to 4 any number if we substitute, because between 1 to 4 means more than 1. If we substitute it gives positive. So this I can, since it's positive, here I can write. We get positive value, right? So between 1 to 4, the x minus 1 gives positive. So I can write between 1 to 4 mod x minus 1 will become x minus 1 dx. Again now you can see between 1 to 4. If we come to this, At 2 this will be 0. The function at 2 this will be 0. Correct? I should split this. At 1 to 2, 2 to 4 I should split this. Why? Because between at 2 this will be 0. So with 1 to 2 it gives negative. Between 2 to 4, more than 2 if you substitute here it gives positive. So here I can split this 1 to 2 mod x minus 2 dx. That means here, since I told you this one, first I will split this mod x minus 2 dx. But here between 1 to 2 this gives positive. You write mod x minus 2 dx. Between 2 to 4 I can write this one mod x minus 2 dx. Coming to now 1 to 4. If we substitute more than 1 to between 1 and 4 any value, it gives negative. So I can write this one 1 to 4 minus of x minus 4 dx. X minus 4 dx. Correct. Now you can see this one. Then this is general simplification. Now I can do that. Here I can write this one. I can write x square by 2 minus x. I can apply the limit 1 to 4. And this one I can write. Since 1 to 2 this is you will get negative. So I can write minus integral 1 to 2 x minus 2 dx. This one again 2 to 4. If we take 2 to 4, 2 point something, it gives positive. I can write 2 to 4. This mod x minus 2 will become x minus 2 dx. This already I have taken this one minus 1 to 4 x minus 4 dx. So I can do like this. Why I have not done here, I will tell you the reason now. See, when I have taken this one, I can do like individual x square by 2 minus x. That is one method. Some people they may do directly. Sir, why can't you take x minus 1 whole square by 2 derivative of x I should divide. That way also you can take it. That is fine. You can also do that way also. No problem. Substitution you can do that. But this way also you can do that. Substitution two ways. Either x minus 1 whole square by 2 you can write. Here x minus 2 whole square by 2. Here x minus 2 whole square by 2. X minus 4 whole square by 2 also you can write. Or you can take it individually also. Both are correct. Both options are correct. Now if we take this, you can see now. Understood that. That way also you can solve the problem. Now because this is generally this is familiar with you can write like this. X square by 2 minus x 1 to 4. I can write substitute this is 4 square. 16 by 2. 8 minus upper limit I can write 8 minus 4. Right, because 8 minus this in the place of x. 8 minus 4 minus lower limit 1 by 2. I can write minus 1. But if you do like this, you make it calculation will be more. You make it more calculation it comes. To avoid this way I can do. Here also I can do that. To avoid this I can do here. To avoid this, what I will do here, instead of doing this I can reduce this one. See, I can do this is also correct. What I have done also right only. Even what I am suggesting now, if we do like this one, I can directly 1 to 4 x minus 1 dx. 1 to 4 x minus 1 dx. Now you see, since let it be x minus 1. So I can write directly now x minus 1 whole square by 2. Derivative of x minus 1 only, limits 1 to 4. So this way also you can do. Minus x minus let it be one function. Now you can write x minus 2 whole square by 2. Limits I can write 1 to 2. This one x minus 2 whole square by 2. Limits 2 to 4. I hope you understood. Why? Because let it be x minus 1 as one term. There will be like you know integral x power n plus 1 by n plus 1. X minus 1 whole power 1 plus 1 by 1 plus 1. Derivative of x minus 1 I should divide. Then we get 1 only. Same thing x minus whole power 1 plus 1 by 1 plus 1. X minus whole power 1 plus 1 by 1 plus 1. 2 to 4 minus this one. X minus 4 whole square by 2. Limits 1 to 4. I can substitute like this. The method what you have done, that is also correct. Don't get that is also correct. Both are correct. Now, substitute the upper limit minus lower limit in all the terms. Substitute upper limit lower limit for all the terms. If we substitute this, I can write this one. 4 minus 1, 3 square, 9 by 2. Minus it comes, if we substitute 1 here, that will be 0, right? Lower limit, 0 it comes. Minus, this one upper limit, If I substitute upper limit 2 minus 2, this will be 0 minus lower limit, because I have taken 1. Lower limit is 1. 1 minus 2 minus 1 whole square. 1 by 2 it comes. So you will get 1 by 2. This one. If I apply this one, 4 minus 2. 2 square, 4 by 2, 2. Minus lower limit to 0 it comes. Minus. Now if we substitute here, upper limit 4. That will be 0 minus. Lower limit 1 minus 4. Minus 3 whole square, 9 by 2. So here calculation will be simple if we do this method. So you can check that now what it comes now. This is 9 by 2. Here plus 1 by 2. Correct. Plus 2. And this is plus 9 by 2. Correct. Now you can see this one. 9 by 2 terms we have. 2 into 9 by 2 plus 2 plus 1 by 2. So I can write this one. 9 plus 2, 11. 11 plus 1 by 2, simplify. It comes 23 by 2. So that is the required answer. Now my dear students, is it clear? I understood this method. Please let me know. If any confusion in this method, I will repeat this problem again. Please discuss with me. Should I repeat this? I understood this. Is it clear? Then fine, if it is clear, it's good. The method you learn, you practice again and again this problem, it is good. Because that type of question they're asking, chances are there, 99% chances are there, they're asking using the modulus function or step function. Many times I've observed in CBSE, frequently they're asking modulus function. You should be careful with this. Always they're asking this model. Now, you can see the next one. Integral 0 to 3 by 2. Integral 0 to 3 by 2. Integral 0 to 3 by 2. 3 by 2 mod x sine pi x dx. Integral 0 to 3 by 2 mod x sine pi x. This is x only. Don't think about this is x. Here also this is x. Mod x sine pi x dx. See careful here again, modulus function 0 to 3 by 2. Think about the angle. Okay, the inside value positive or negative I should decide. So just simple concept. What I will do now here, I will consider starting 0. Here integer 1 I will take. Up to 3 by 2 means like 1.3 by 2 I will consider. So this value, if we substitute pi into this x value 0, pi into 0, 0, just I am giving an idea about this one. Pi into 0, 0 and pi into 1, this is pi. And pi into 3 pi by 2. I am talking the value of pi x. So this is the value of pi x. This is the x value. I haven't understood here. This is, don't confuse here. This is the x value 0, 1, 3 by 2. Because x limit 0 to 3 by 2. So I have written here, this is x value, this is pi x value. Correct? Not pi n. Pi into x value. Because I want to check this. 0 pi. Because clearly we know x values are positive. So this is positive. I should decide about sin pi x value. What about, I should decide what is sin pi x. Clearly x is positive here. What about sin pi x value? Because again you should remember the modulus function. Mod x equal to x when x is positive. Mod x equal to minus x when x is negative. That you should remember. Between 0 to pi you can think. Between 0 to pi, if you think between 0 to pi, you can see 0 to pi means in first and second quadrant, this value. If we substitute pi x, it gives here between 0 to pi, this value comes positive. You will get positive value. 0 to pi, if we take this value, total I have written this is pi into x, this is the value. 0 to pi, sin entire value becomes positive. Between pi to 3 pi by 2. Pi to 3 pi by 2 goes to third quadrant. In third quadrant, sign is negative. I hope you understood this. 0 to pi, sign will be positive, and pi to 3 pi by 2, sign will be negative. So, I can split this function now. 0 to pi. I can split this 0 to pi. Correct. No sir, x values. This is pi x value to decide. I should write x values 0 to 1. 0 to 1 I can write mod x sine pi x dx plus 1 to 3 by 2. 1 to 3 by 2. The model is important. 1 to 3 by 2. X sine pi x dx. I have taken like this. X sine pi x dx. Now you see here. Using this data, I can split 0 to 1. This is positive here. So then I can write integral 0 to 1 x into sine pi x. This is I can write sine pi x. Sine pi x dx plus 1 to 3 by 2. This will be negative. I can write minus of x sine pi x dx. It comes like this. Now I should use integration by parts. I should use integration by parts here. But we know that the function, the first function, second function, we use IITJEE, algebra and trigonometry. So I can consider this is first function. So remember, this is first function, this is second function. Here also first function, second function. So we know the integration by parts. Integral, just remember, what is integral first function into second function? If we have first into integral of second minus derivative of first, integral of second, whole integral. Just remember this concept. Because using IITJEE, I have written first function, second function. Then you can do this one. This problem is very simple problem. I can write this one. You can see this. After writing this, now I will do this problem. Just observe here. So first function is x into integral. They will discuss about that. Integral sine pi x. Integral sine pi x. See, both are same. What I will do, I will do one thing here. To save the time, what I will do here, just let it be. This is like I will write equation 1. Without limits, I will find first integral x sine pi x. Because both set same function. Limits will be different. Then after that, I will resubstitute the value. So we can save the time. So if I take this one, this is first function, second function, dx. Now I will do this one. I can write first into integral of second function minus derivative of first function d by dx of x. I can write here d by dx of x, integral of sine pi x. This is sine only. You can consider integral of derivative of x. I can consider this one. Right. When I have written this one, this we can see here. This is d by dx of a integral sine pi x. I can consider this one sine pi x dx, again whole dx. This is what I told you here. Now this will become now x into integral of sine minus cos pi x. By derivative of pi x, this pi I should divide. It comes like this. Correct. Now this one minus derivative of x is 1. Integral of sine pi x minus cos pi x by pi dx it comes. Now we can write this one. This value I can write. This will be minus x cos pi x by pi minus minus plus into 1 by pi integral cos pi x dx. Integral cos pi x dx. Correct. Integral cos pi x dx. Now you can think this one. Integral cos pi x is sine pi x. So I can write now this one minus x cos pi x by pi. This is 1 by pi. Integral cos pi x sine pi x. The derivative pi x is pi only. I can divide. It comes like this. Here I am not writing constant c because I am going to apply like definite integrals, right? That's the reason I am not. Actually I should write, if I am considering indefinite integral, I should write c, but here not required. Just to get an idea about this, I have done this. Correct. This value will get minus x cos pi x by pi, correct, x cos, this is pi x only, x cos pi x by pi, plus you will get 1 by pi square into sin pi x, like this, correct. Now I will go back to the previous problem, because this is what I have done, integration by parts. Just now I can explain, you can see this. I will go back here, because why I have taken that, here also I have x sin pi x, here also I have x sin pi x, limits are different. I took this is 1. If you follow integration by parts, this is important. Follow integration by parts. Correct, you should follow integration by parts. According to that I have done. Wherever integral sin pi x minus cos pi x by pi, that is important. We have integral cos pi x. You should divide the derivative of pi x is pi, I should divide. This is cos pi x. Same thing. I can repeat. Integral cos pi x, you will get sin pi x by pi. So from 1, 0 to 1, 1 to 3 by 2, this minus comes outside. I should consider from 1. So what I will write from 1? So I can consider now from 1, I can write integral 0 to 1, this value I can write. So now I can apply the limits. From 1 directly I can apply the limit, this 1 minus x cos pi x by pi plus sin pi x by pi square, limits I can apply 0 to 1 minus, same thing, minus x cos, the patience is required to solve this problem, minus x cos pi x by pi plus sin pi x by pi square, take the limits 1 to 3 by 2. 1 to 3 by 2. Why you got minus? Look into the previous one, from 1, there minus is there. We will get this one. This is same, limits are changed, different. Now you can apply, you can substitute the values now. We get the required answer now. If I substitute the values, upper limit, if we substitute 1, minus 1, it will come cos 180. We will get cos 180 by pi. If upper limit plus sin pi, this is sin 180, it comes sin 180 by pi square, upper limit, minus if we substitute lower limit, this will be 0. At sin 0, this is also 0, it comes. This is a part here. I have done this one, pi square, this is a part. Now minus, you can same thing, apply the 3 pi by 3 by 2. Upper limit is 3 by 2. Just you can go through this. Upper limit is 3 by 2. Correct, you can see now. When upper limit is 3 by 2, if we substitute here, minus 3 by 2, cos 3 pi by 2. If we substitute 3 by 2 here, minus 3 by 2, cos 3 pi by 2. Minus 3 by 2, cos 3 pi by 2 by pi. Plus, this will come sin 3 pi by 2. It will come sin 3 pi by 2 by pi square. Just observe here, I am substituting the values. 3 pi by 2 minus, if I apply 1, this will come minus cos pi by pi, and this will sin pi by pi square. So it comes like this. Just verify. I can do directly also. To understand, I have written each and every step. Now you can see this one. Minus cos 180 minus 1. Minus 1 minus 1. It will be 1 by pi. 1 by pi. It will come like this. You should be careful with the values. Sin pi 0. This will be 0. This is everything 0. This is the first bracket I can get. This one I will get the first bracket. Correct? You understood? Cos 180 is minus 1. This 1 by pi. Coming to here. You observe this one. This part is I can write. Right, this part is over, this first bracket is over. Coming to the next bracket, you can see cos 3 pi by 2 0. This will be 0 here. And this one plus sin 3 pi by 2 minus 1. You get minus 1 by pi square. Minus 1 by pi square it comes. Correct. Now you can see here minus of minus plus cos 180. Here as you can see minus I can write cos 180 minus 1 minus plus 1 1 by pi. Sin 180 is 0, it comes like this. This values it comes like this. Now if I simplify finally, you can see what it comes now. This is the value it will come 1 by pi. Here plus 1 by pi square, and this is minus minus plus, it will be 1 by pi. It will go 1 by pi. So your answer is 2 by pi plus 1 by pi square. So the patience is required to solve this problem. Not that much difficult, easy only this one. Not that much difficult. Just you go through that long procedure here. So when I have taken, just I will repeat quickly, I will revise this. So the 0 to 3 by 2 mod x sin pi x dx. Then according to this x value 0 to 1, 1 to 3 by 2. Pi x, verify pi x value 0, pi and 3 pi by 2. According to sign value between 0 to gives positive, pi to negative, you split the function is positive here and negative here. Then use integration by parts. Then you can simplify. This one you can simplify. After simplifying, substitute the equation from 1, then substitute the values, you simplify, it gives the value 2 by pi plus 1 by pi square. Please verify that. Still if you have doubt, you can also ask me, I can explain again that problem. I hope is it clear, Anurag and Yuvraj, Shweta, Kushala, anyone, is it clear? I hope you understood this. Is it clear? Because do it one more time this, that is important. If you do it one more time, then you'll be confident about this. Do one more time this, don't leave this problem, you should do that. Taking time, but model is important here. 9. Next, integral 0 to pi by 4. I will do the next one. Integral 0 to pi by 4 log of 1 plus tan x dx. Integral 0 to pi by 4. Integral 0 to pi by 4 log of 1 plus tan x dx. Integral 0 to pi by 4 log of 1 plus tan x dx. Log of 1 plus tan x dx. So this is the problem. Here always you can remember 0 to a, f of x dx always equal to 0 to a, f of a minus x dx. I can use this concept here. You can consider this problem, let I is equal to, you start I is equal to, apply this formula. Then 0 to pi by 4 log of 1 plus tan of pi by 4 minus x, tan of dx, you apply this, tan a minus b. Simple problem but important model. I can write integral 0 to pi by 4 log of 1 plus, this will be tan pi by 4 minus x, 1 minus tan x by 1 plus tan x. Correct? 1 minus tan x by 1 plus tan x. This is tan x here. Tan x dx. You take LCM here. If you take LCM, then 0 to pi by 4. Integral 0 to pi by 4. This will be log of, you take 1 plus tan x plus 1 minus tan x by 1 plus tan x. This is tan x only. Try to understand, this is tan x only. Correct, I have written like this dx. Now when I have taken like this, you can see now, this plus tan x minus tan, I can eliminate this. You will get integral 0 to pi by 4. Integral 0 to pi by 4. This will be log of 2 by 1 plus tan x dx. 2 by 1 plus tan x dx. So I can write log m by n, log m minus n. This is tan x. Just observe, this is tan x. So apply log m by n formula here. Then you apply log m by n formula here. There you can see this is tan x. If I apply this is, I can write 0 to pi by 4 log good to minus log of 1 plus tan x dx. I can write like this, correct? But this side we have I is equal to left side. Same thing if I separate the two terms, you can separate the two terms now. So you write I is equal to, I can write this one again, I is equal to, if we take log 2 outside, log 2 0 to pi by 4 1 dx minus 0 to pi by 4 log of 1 plus tan x dx. See, this is the given problem. This is log of 1 plus tan x dx. So that will be I. So I can write I is equal to log 2. This will be log 2. Integral 1 dx is x. Limit 0 to pi by 4. This is I. Transfer I this side. You will get 2y is equal to, if it on this side, problem is simple, important one. You write 2y is equal to log 2. Apply limits pi by 4 minus 0, it comes pi by 4 log 2. So the conclusion will be I is equal to pi by 8 log 2. This is the required answer. Pi by 8 log 2. The model is important. Just remember that. Pi by 8 log 2. Easily can solve that problem. Right. Not that much difficult, we can solve that problem. The next one. See here the pi by 8 log 2. I think it's clear, the simple problem, concept is simple. 0 to pi by 4, apply. X means pi by 4 minus x. Right hand of a minus b, simplify. Log m by log m minus log n. You separate two integrals. Repeat I again. Transfer I left side. You simplify that. It gives I equal to pi by 8 log 2. Alright. Next one. I can do that. Integral e power tan inverse x into integral e power tan inverse x. This is the thing here. We have completed this. Next, integral. Right, integral e to the power of tan inverse x into, I can write 1 plus x square by, I can write 1 plus x square dx. This is the problem I have taken here. So in this problem, the substitution here, put tan inverse x is equal to t. You put tan inverse x is equal to t. So this is easy, simplify. Tan inverse x is equal to t. So x is equal to tan t, it comes dx equal to secant square t dt. It will be secant square t dt. Correct. Now I can write this problem. This will become e power t. If we substitute here, 1 plus x equal to tan t, 1 plus tan t, x square, so tan square t, by I can write 1 plus tan square t into dx secant square t dt. Again we know 1 plus tan square t secant square t. Wherever 1 plus tan, I can write secant square t. Correct. Now I can simplify. See, we know 1 plus tan square t equals secant square t. Here also you can see now this one and this one, 1 plus tan square t. I can write e power t into 1 plus tan square t. See, I can write this one. So tan t plus secant square t by secant square t into secant square t dt. Correct. Now you can see now I can eliminate this one, right? In e power t f of t dt, we know formula. Integral e power t like f of t plus f dash of t dt. The answer will be e power t into f of t, right? This into this. The derivative is here. Correct. Same thing. Derivative of tan t secant square t. This is square, right? Because this is secant square t. Correct. This will be, we know that this is secant square t. So then I can write answer according to this e power t into tan t. Correct. The answer I can write e power t into derivative of tan t secant square t. So the answer will be e power t into tan t I can write. So which is equal to e power t into tan t plus c. But we know that tan t is equal to x. E power t means we know that. I can tan t means x into e power tan inverse x plus c. That is the required answer. X into, this is x into e power tan inverse x plus c. Correct, x into e power tan inverse x plus c. Like this you can write. This is one of the important problem. Next one. Suppose if they are asking, next one, integral 0 to 1 sin inverse x dx. Integral 0 to 1 sin inverse x dx. This is a previous problem. You have taken this simple problem, this. Now I am going to do now another problem. Integral 0 to 1 sin inverse x dx. When I am doing this, integral 0 to 1 sin inverse x dx. Alright, you can see now. Integral 0 to 1 sin inverse x dx. Sin inverse x dx. This is one of the important problem, integral sin inverse x dx. See, in this problem, when they are asking integral sin inverse x dx, in what way you should simplify this problem? Integration by parts. You should learn here sin inverse x, integral tan inverse x, integral x sin inverse x tan inverse x. These are all important problems. Integral sin inverse x dx. To solve this problem 0 to 1, I can write this one. Sin inverse x is the first function and 1 is the second function. So I can consider this is the first function, 1 is the second function. Using integration by parts, first function into integral second function minus derivative of first function d by dx of sin inverse x integral 1 dx whole dx. You should write this. Or limit 0 to 1 I should apply, right? Limit 0 to 1. I can apply limit 0 to 1. So this will become 1 dx is x. So this will become x sin inverse x. Minus derivative of sin inverse x, it will be 1 by root of 1 minus x square. 1 dx is x. It will become x dx. Correct. It will become x dx. X by root of 1 minus x square. Now you should be careful here to do this problem. This is an important concept. You should be careful. What I am going to do now? X, because again, for this one I should apply the limit 0 to 1. After completing integration, then we can apply the limits. But here, you see the derivative of 1 minus x square will be minus 2x. So this I can make it for our convenient x sin inverse x. This can write plus 1 by 2 minus 2x by root of 1 minus x square dx I can write. This is integral. So I have taken like this, derivative of 1 minus 2x. To get here, this minus take inside 1 by 2 minus 2x dx. Limit 0 to 1. Sir, why the purpose you have taken this? The reason I will tell you now. Remember, just right side I will write, you say remember, integral, write integral f dash x by root f of x dx. This will be equal to 2 root f of x, right? The formula 2 root f of x plus the constant, okay? This is 2 root f of x. Derivative of this is here. So then I can write this one x sin inverse x. Write x sin inverse x. Right. Because x sin inverse x. Then you can use this formula. Root f of x, derivative this one here. Derivative is here. I can write now. This using that concept I can write x sin this one plus 1 by 2. This using this formula. 2 root of 1 minus x square limits 0 to 1. Then 2 will get cancelled, right? Then apply the limit now. If we substitute the limit, gives final answer, right? Substitute the limit now. If we, again I will repeat that. If we substitute the limit, see the upper limit, substitute 1 into sin inverse 1. It will be sin inverse 1. Then 1 if we substitute, that will be 0. Minus lower limit, substitute 0, this will be 0. This will be root 1, it will become 1. So sin inverse on pi by 2. Your answer will be pi by 2 minus 1. That is your answer. Pi by 2 minus 1. My dear students, is it clear? Dear students, is it clear what I have done? Just go through once again. This you observe here 0 to 1 sin inverse x dx. Sin inverse x into consider 1 as the second function. Use integration by parts. Then after that, you remember right side integral f dash x by root f of x, 2 root f of x. Use that formula. Simplify. Apply the limits. It gives pi by 2 minus 1. It gives pi by 2 minus 1. This is the problem. Pi by 2 minus 1. Right. Because 0 to 1 sin inverse x dx equal to pi by 2 minus 1. This is the problem is most important one. So what I will do here, even similarly they may ask integral tan inverse x dx or integral x tan inverse x dx. That question they may ask. Or integral x sin inverse x dx. You can try those problems also. Integral x sin inverse x dx also. Questions are important that one. Once if I explain that integral x sin inverse x dx or integral tan inverse x dx. So what I will do now here, I will explain now integral tan inverse x dx. So integral tan inverse x dx. Tan inverse x dx. Now you think in this problem, when they are asking the same concept here, I can write only one function here. I can write tan inverse x into 1 dx. This is tan inverse x into what? Tan inverse x into 1. You consider here this is first function, 1 is second function. You can consider that. Now after considering here, I can write first function tan inverse x. This is the first function tan inverse x integral 1 dx. Integral derivative of first function d by dx of tan inverse x integral 1 dx whole dx. So this is integration by parts. Just have integration by parts. Now you can simplify here. You can simplify. Just I am using integration by parts here. Just you can simplify. Right. So what I am doing now, in the simplification you can observe here. Just I can write this one, which is equal to tan inverse x. Integral 1 dx is x minus derivative of tan inverse x 1 by 1 plus x square, right? It will come 1 by 1 plus x square. Derivative 1 dx is x. I can write here x dx. Correct? Now it is x by this derivative 1 dx is x dx. I have written this is dx. Again same concept. Just you remember in the previous I told you integral f dash x by root f of x dx. Sorry, there is no root here. F dash x by f of x dx. If it is like this, I can write log mod f of x plus c. It comes like this. The derivative of 1 plus x square 2x. Here 2 is missing here. So this I can write x tan inverse x minus 1 by 2 2x by 1 plus x square I can write. The denominator right. You can see this. Correct. Now you can write. Correct. I can write this is 1 plus x square. 2x by 1 plus x square dx. Now you can see this one. I can write this one using this formula. You can use this formula now. You can use this formula. This will become x tan inverse x. X tan inverse x. So this will be tan inverse x. This will be minus 1 by 2 log mod 1 plus x square. plus c. Log mod 1 plus x square plus c. Minus, this will be our answer here, right? That will be our answer. Integral tan inverse x dx. The most probable questions, still I should complete few more questions are there under like 3 or 4 marks, long answer type questions. Around 6 to 7 I can complete tomorrow, but today again one small problems are there, 1 or 2 related to this. I want to complete this topic. So just I think if you are okay, I can continue another 5 more minutes. Is it okay? Another 5 more minutes. Can I continue another 5 more minutes? Then fine, I can continue now. You can say this is right. Integral, suppose the same related problems I can complete similar question easy for you, right? Integral x tan inverse x dx. Integral x tan inverse x dx. Suppose if they are given like this, integral x tan inverse x dx. Now think again here, this is the first function, x is the second function. Always isolate, remember isolate. So I will inverse logarithm algebra trigonometry exponential function. This is the order, inverse function. So I can write the first function tan inverse x, integral x dx minus derivative of tan inverse x. I can get derivative of tan inverse x d by dx of tan inverse x d by dx of tan integral x dx whole dx. I can consider whole dx. Now you can see this will become, we know integral x is x square by 2, x square by 2, correct? You can remember this will be x square by 2 tan inverse x, correct? That will be easy, it comes now. Integral x dx is x square by 2 tan inverse x. Is clear? This is tan, this is x square by 2 minus derivative of tan inverse x 1 by 1 plus x square x dx x square by 2 dx, correct? Now see in this problem it comes now x square by 2 tan inverse x. This minus 1 by 2 I can write. Since both degrees are same, this is like improper fraction. When it is improper, x square is to divide 1 plus x square. Instead of dividing, what I will do, try to get denominator in the place of numerator. We have this is x square. This term is x square. I can write 1 plus x square minus 1 by 1 plus x square dx. This will be easy. Now I can split this. I can write x square by 2 tan inverse x minus 1 by 2, this by this, 1 minus 1 by 1 plus x square dx we can write. How you got this one? Because I divided this by this, correct? So I got this one. So that you know this is 1 plus x square. You split this by this is 1 by this. Now I can complete within one more step, the problem will be completed. So this will be x square by 2 tan inverse x minus 1 by 1 dx is x 1 by 1 plus x square. This will be tan inverse x plus c. That's all, the problem will be completed. X tan inverse x plus c. Like this you can complete this. Now here I am going to give problem. Again the main questions are around 5 to 6 problems. Tomorrow I can complete that. For all essay questions, maximum I covered that. Any specific questions if you want, please send me and I can tell you that. Please send me either WhatsApp me or you send me in the chat box. You can send me the questions whichever you want. I can do if you see any question papers. Because I am covering previous papers also. All questions which is more number of times repeated questions also I am doing. I am doing more number of questions also. So what I am suggesting you can try 2-3 problems I will give now. You try these problems. So this I completed now. You try 2-3 problems. Then I can, just today I will give 2-3 problems. You can try those problems. Tomorrow also I can discuss those problems. I can discuss tomorrow those problems. Just you can note down this after this. Just you try to practice these problems. So what I'm doing now, integral x sine inverse x dx. If you learn this, even if they give limits also you can do that. You try this. This is one of the problem. Another one, I can integral 0 to pi by 4 sin x plus cos x by 16 plus 9 sin 2x dx. Tomorrow's discussion I am writing here. Sin 2x. These are the problems tomorrow I will discuss. Sin 2x dx. The questions what I am going to explain tomorrow. Next, integral 0 to pi by 4 root to tan x plus root to cot x dx. Without limits also I can tell this problem. Root to tan x, root to cot x dx. Tomorrow discussion. Root cot x, root tan x dx. This problem I will discuss tomorrow. Again, the problems what I am going to discuss tomorrow. Integral, I can write pi by 6 to pi by 3. Pi by 6 to pi by 3. 1 by 1 plus root to tan x. Pi by 6 pi by 3. 1 plus root to tan x dx. Next, integral 4 to pi. Just one more minute I will complete the problem. These are all tomorrow discussion. Integral 4 to pi x by 1 plus sin alpha sin x dx. I can discuss this problem. Next, integral sin x sin 2x sin 3x dx. This also I can discuss tomorrow. Next, integral sin, you can see these are the problems to discussion. Around 6 problems are given. So you try to, still 2-3 problems are there. All important questions only. So these problems I am going to explain along with these 6 problems. Another 3 more problems are there. Around 9 problems. Around 9 problems I will explain tomorrow. That will be with this almost integration part I am going to complete tomorrow's session. It covers maximum all the number of questions. Tomorrow's session I will complete. After that I will start the next chapter. Because area is only one session, we can maximum 1 or 2 sessions we can complete areas. I can do that. I hope you think is clear. So those questions what I have given I will discuss in the next session. Along with 3 to 4 questions I may discuss. Around 9 to 10 questions tomorrow discussion will be there. Right. Then thank you. Thank you and good night. See you in the next class. Okay, fine then. See you in the next class. Bye bye. So your views, comment box you can apply. If you like the session, go ahead. Thank you. See you in the next class. If you understood, if you like the session, or in the comment box also you can express. Still, if you want any more problems, please update me in that, I can do that. Fine then.